we did this on our test, okay? This is one of those exceptions, like you think that this is tangent x, secant x, and you put it in a square, okay? And you say, this is the parentheses, so I make this my u. But remember I said 95% of the time, like not all the time your parentheses is u, 95% of the time. So that's how I take back what I say, okay? So instead of making your u secant x, it's actually easier to make your u what? Tangent x, okay? Let's take the derivative of this. Okay, so guys, I'm in your notes. And actually pull out your formula sheets if you have them. We're gonna add 3 new formulas today. All right, so the derivative of tangent x is secant squared x times the derivative of x, which is just 1, so you don't have to put the 1, okay? And then we have to solve for dx. So remember, real algebra, guys, I'm gonna cross multiply, and I'm gonna cross solve for dx. So dx is really du over secant squared x, okay? Then there's 2 things that you have to replace. Your u, where is my u? Right there, and my dx right there, okay? And so you have to replace, you can replace those, but you can't replace anything else. So what I have is u times secant x quantity squared times, and I'm going to copy this dx. So this dx is du over secant squared x, okay? And some of you guys are like doing a whole bunch of things at one time, and that's why it's not working out really well, okay? So I would just do it the way I'm teaching you to do it, one step at a time. Circle what you want to replace, okay? Put in just those things. Don't put in anything else, okay? So then do my x's cancel out? Yes. Do you guys see that? And so this becomes the integral of u du, okay? And is this an easy antiderivative or something on my formula sheet? It is an easy antiderivative, okay? And there is a great answer. It's not the right answer though, okay? If you want the right answer, you gotta go back and plug in your u, because there wasn't any u to begin with in the problem in the first place, okay? So plug in your u, and that is the right answer. Okay, you guys good with that? All right, today, I want you guys to look at these 2 problems here. 1 over x squared and 1 over x. Okay, so how would you do a quotient problem like this? What do? Okay, rewrite it. You guys good? Okay, once I move it up and I rewrite it, okay, you agree. You add 1, divide by what? -1, the new exponent. So isn't that x to -1 over -1 plus c? Isn't that my answer? And if I were to rewrite this, okay, wouldn't this be negative x to the -1 plus c? And if I were to rewrite that, wouldn't that be -1 over x plus c? Is everybody with me so far? Okay, so that's how you do this problem. Let's go over here. Rewrite this one, guys. Okay, guys, we're in your notes. So you picked up your notes in the front, okay, today. I'm going to add 1, divide by ding, 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 ding. Did you hear the ln bell? What's wrong with this? Let's try it again. Let's see if it'll happen again. I'm going to add 1, divide by what? Ding, 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 ding. Divide by 0. What happens if you add 1, what's my new exponent? 0. Divide by 0. So my answer is 1 over 0. Is it possible that this answer is undefined? Let's think about it. What is 1 over x, the integral of 1 over x? Guys, remember a few weeks ago, we learned the derivative of ln of x is what? Isn't it u prime over u? And isn't this my u right here? So what's the derivative of x over x? Right? Isn't the derivative of ln of x 1 over x? Well, then that means the integral of 1 over x is what? ln of x, okay? X. And actually, when we do it this way, we actually put it in absolute values. It's kind of weird. When you go forwards, you don't have to have any absolute values because you assume that this is positive, or else you couldn't go forward. But this here, this has to be forced to be positive, or else you won't have an answer, okay? And so, guys, this answer here is actually ln of x plus c, okay? And that is your new formula today. Your new formula is, when you see this, so it's on the second page of your formula sheet, guys, the back of, the first paper. So the second page of your formula sheet, kind of on the right middle, okay, you have 1 over u du, okay? If you have 1 over u du, that is the ln of u plus c, okay? And if it helps you, you might want to put this x1 with it, because sometimes we have the 1 over u du, and you know this is ln of u plus c, but when you replace it with an x, you're unsure of what it is. I mean, it's pretty obvious now, but it gets complicated. When you guys start doing problems by yourself, you get confused. All right, so these are your two formulas. This is the one that goes on your formula sheet because we do u substitution. Okay, so what does this mean? This means anytime that I get the integral of u negative 1, that answer, does that make sense, is going to be an ln of u plus c. Every time I hear the ln bell. And what is the ln bell? Well, when you add 1 and you divide by ding, 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 you can't divide by 0. Does that make sense? Then you hear the ln bell, you go backwards and you say, oh, this must be 1 over u du, which is ln of u. Okay, so let's talk about what all of this means. Let's look at a problem. Okay, so you guys have this problem on your notes, okay? The way you would approach this problem is you would figure out what your u is, okay? And when you have division, like a numerator, a fraction, a numerator and denominator, believe it or not, you have parentheses here. Guess where your parentheses are? Here and here, right? They're families, right? Each one is a family by itself. So you have to choose between these two parentheses, what would you make your u equal to? The bottom one. Why would you pick the bottom one and not the top one? Yeah, that, okay. And also because this power is higher than this power, and you're about to take the derivative, okay? And so when I take the derivative of this, what I'll get, so usually you pick the higher power, okay? So when I take the derivative, do you see you get 5 minus what? 3x squared. Okay, solve for dx, guys. Force this into a fraction. Cross multiply this. Force it into a fraction, cross multiply. You guys are really good at this now. Okay, you're going to substitute two things. So let's go back here. What two things am I going to substitute? My u, which is right here, and my dx, which is right here. If I didn't circle it, I'm not going to substitute it. So I have 5 minus 3x squared over this bottom here is my u. Do you see that? So that's u times this dx here is right here. So I'm going to replace this dx right there. So that's going to be du over 5 minus 3x squared. Okay, so what I'm going to do here is this is going to divide out. You guys agree? Okay, so what I have is 1 over u du, which you guys know is the same as du over u, okay, because this can bounce out and then. All right, so let me just make sure you understand that. This is the same as this. So if you see either one of these, okay, this is should be an easy antiderivative or something on my formula sheet. Is it on my formula sheet? Well, now it is. What is it? The ln of u plus c, and that is a great answer. It's just the wrong answer because you need to go in and put in your u. So your u is here, 5x minus x cubed. So you go back and put in your u, and there you will have the right answer. Okay? All right. Let's try another one. So this one right here. Okay. Same idea here. This could be my u or this could be my u. Okay. So which one between these two, which one's a better one? 1 plus x squared, just because it has a higher power. Okay. If you have two polynomials, you want to pick the one with a higher power. All right, let's take the derivative of this and let's solve for dx using real algebra. Real algebra, solve for dx. Okay, we're going to replace two things. What two things do you replace? Your u, which is this right here, your dx, which is this right here. If I don't circle it, I'm not going to replace it. And I ask myself the question, do my x's cancel out? Do they? Yes. What's left over though? 3/2. Pull that 3/2 out, okay? And that way it'll uncloud this integral that I need to take. So here's a question for you. This should be an easy antiderivative or something on my formula sheet. What is it? It is something on my formula sheet. Okay, do you guys see how this works? Everybody good? Now this is actually not the right answer though. What do I need to do to make this the right answer? Yeah, go in and plug in your u, okay? And there is the right answer. Okay, let's go to this problem right here. Okay, now this one looks a little bit funkier, okay, but the same idea is the same. And I'm going to tell you I'm going to tell you make your u equal to cosine x. Okay, I'm going to tell you to make your u equal to cosine x. That's a trick in a second. Yeah, you're jumping ahead. That's good. You're seeing that. Okay, I'm going to make the u equal to cosine x. Becca was saying, do we always make the bottom our u? That's actually a good start. It doesn't always work, but it's actually a good start. Okay, so u equals cosine x, du dx equals, okay, we got to think about this for a while. I'm taking the derivative. What's the derivative of cosine x? Okay, so negative sine x. Then solve for dx. Okay, again, guys, I'm going to force this into a fraction, cross multiply. When I solve for dx, I get du over negative sine x. Okay, I'm going to replace two things. I'm going to replace my u, and I'm going to replace my dx. Okay, so what I get here is sine x over cosine x, but that cosine x is my u, times dx. This dx right here is going to be du over negative sine x. You guys good so far? Okay, here's the big question. Do my x's cancel out? Because if they don't, I need to go pick another u. Do they cancel out? Yes. What do I have left over, though? Negative 1. So do you see this is negative times 1 over u du. I mean, you could say negative 1 times if you want to, but it's 1 over u du. And what is the integral of 1 over u du? Is it something, is an easy antiderivative or something on my formula sheet? It is on my formula sheet. And there is your answer. Okay, that's a great answer. Just turns out it's the wrong answer. Okay, how do you get this right answer? Okay, you plug in your u. Now, I want you to take a look at this. Okay, this problem was sine over cosine. Okay, and this answer is negative ln of cosine x plus c. What's sine over cosine? Tangent. So guys, go to your formula sheets, please. Go look for the integral of tangent u du. Okay, and please go put this formula in. Okay, the integral of tangent u du is equal to negative ln of absolute value of cosine u plus c. And up to this point, you thought that you knew the integral of tangent u, but you didn't. You only knew the integral of secant squared, and you knew the derivative of tangent, okay? But this is the first time you actually have the integral of tangent u. You probably wish you didn't know, okay? But this is what you have. It should be an integral somewhere. Should be in the trig integral somewhere. Do you see it? Okay. So go ahead and fill that in, and then let's go ahead and talk about this problem here. Okay, let's do this first problem here. 2x over x squared plus 1. All right, I'm going to make my u the larger polynomial, okay? So this is going to be u equals x squared plus 1. The derivative of this is 2x, right? So I'm going to make my u this right here. And if I solve for dx, I cross multiply, I'll have dx is equal to du over 2x, okay? Now I'm going to replace two things. I'm going to replace my u, which is right here, and I'm going to replace my dx, which is right here, okay? So this is going to be the integral of 2x over u times du over 2x. Are you guys with me so far? Okay. Do my x's cancel out? They do. What do I have left, though? 1, right? So I have the integral of 1 over u du. This should be an easy antiderivative or something on my formula sheet. Is it on my formula sheet? It is. It's the ln of u plus c, and that is a great answer. It's just the wrong answer. The right answer would be ln of x squared plus 1 plus c. You agree with that? You guys ready for a shortcut? Okay, you should have this on your paper. That's the answer, right? I'm going to erase this. You guys have that on your paper. I'm going to show you a shortcut. Now, this is a shortcut for the ln of u, what we've been doing, okay? But you got to be careful. Like with all shortcuts, you got to meet the qualifications, right, before you do the shortcut. So the shortcut goes like this. And what's going to happen is you're going to do this without meeting the qualifications, okay? And that's when we get in trouble. So if you make your whole bottom your u, so you have to make the whole bottom your u, not part of it. So what students would do is they'll just make this their u and then say that this works. No, it's not okay. The shortcut goes like this. If you make the whole bottom your u, then you take the derivative of the whole bottom, not just part of it, the whole bottom. Do you agree the derivative is 2x? Then if I take that number and I divide it by the top numerator, not part of the numerator, the whole numerator, if the x's cancel out, then I just keep that number. So do the x's cancel out? Yes. What does it cancel out to? 1. So I keep that number. This time it's just 1. Okay. And I multiply it by the ln of whatever I made my u, which has to be the entire bottom. So ln of x squared plus 1 plus c. And do you see I get the same answer? Okay. So this is a shortcut for the ln method, but it only works if 2 things are true. First, the whole bottom is your u, not just part of it. Second, when you take the derivative of the whole bottom, the x's cancel out up here. Okay, so let's try it for this problem. You've already done this problem before. Can you add a squared in there? There's a typo in your notes, add a squared. We've done this problem already. And let's see if we use a shortcut on it, we'll get the same answer. Okay, so the shortcut is this. You make the whole bottom your u. Okay, now at any point on the shortcut, if it doesn't work, if the x's don't cancel out, then the bottom wasn't your u and it wasn't an ln problem. You just go find another way to do it. Okay, so if the whole bottom is my u, what's the derivative of this? 5 minus 3x squared, right? Okay, using real algebra, not the fake stuff, using real algebra is 5 minus 3x squared over 5 minus 3x squared. Do the x's cancel out? Yes. And what does it cancel out to? 1. So this becomes 1 times, and I know you don't have to put the 1 times, but I'm writing it because a lot of times it's not 1. Okay, so whatever it is, you have to write it. So 1 times the ln of the absolute value of the whole bottom. So this is 5x minus x cubed plus c. All right. Okay, you guys do this problem then. See if you can use a shortcut on this one. Okay, so the whole bottom is going to be my u. What's the derivative of the whole bottom? What's the derivative of 1 plus 7x? 7. You guys good with that? You're going to divide the top by that whole derivative. And then you say, do your x's cancel out? 3 over 7. Do my x's cancel out? Yeah, I mean, they're not even there, so that's great. Okay, what number do I have left? 3/7. So you take that number, you multiply it by the ln of the whole bottom, and bam. This is the same thing you would get if you do u substitution. We're doing a pattern method called pattern recognition here, okay? Do you like it? Do you like it better than u substitution? Yeah, just be careful. It doesn't always work if your x's don't cancel out, okay? So make sure your x's cancel out, and make sure you have, you're taking the whole bottom as your u. Okay, so let's try it on this problem, okay? I'm going to make the whole bottom my u. What's the derivative of sine x? Cosine x, okay? Colton, can you put your phone away? Okay, so on the top, using real algebra, cosine x over cosine x. Do my x's actually cancel out? They do. What do they cancel out to? 1. So the answer is 1 times the ln. Of course, you don't have to write the 1, but I'm writing it because sometimes it's not 1. So ln of the whole bottom plus c, okay? And that is the integral of cosine over sine. And I want you guys to think about this. What is cosine over sine? Cotangent. So this is your third formula for today, okay? The integral of cotangent u du is actually the ln of sine u plus c. Okay, so find that in your formula sheet. And we found 3 new formulas today. Okay, I want to kind of help you memorize these a little bit. These are a little bit hard to memorize. But guys, do you see here, remember what we talked about? If the answer starts with a C, then you have a negative, right? This is the tangent one. If the answer starts with a C, then you have a negative. If the answer doesn't start with a C, then you have a positive. I know I'm avoiding this ln, okay, but I'm kind of skipping to this so that my trick works, okay? Also, it gets confusing. Like if it's cotangent, how do you know if it's sine or cosine? If it's tangent, how do you know if it's sine or cosine? Remember, this trick works if you take the ln of the bottom. Does that make sense? So this is actually cosine over sine. So this must be ln of sine. Does that make sense? It's the bottom number. Tangent is really sine over cosine. So that's why cosine is over here. Okay, and that's how I remember it. I actually usually like change it here and then remember what it is over here. Okay, all right, so 2 new formulas for you. And then, yeah, and then you had the ln of u formula too. Okay. You got it? Okay, let's look at these 2 problems. And I want to show you where students get confused. Okay, these problems look similar, okay, but you actually use different methods for them. So let's just try the shortcut I just taught you. Okay, if I make the whole bottom my u and the x's cancel out, then it'll work. If the x's don't cancel out, all you do is go back and make something else your u. That's all it means. Okay, so if this is my u, what's the derivative of x squared plus 1? 2x. Using real algebra, 3x over 2x. Do my x's cancel out using real algebra? What does it cancel to? So this answer is 3/2 ln of x squared plus 1 plus c. Okay, let's go to this side. This is what students do. They grab this and they say, there's my u, and they divide by 2x. What did I do wrong? Yeah, you can't grab whatever you want. You don't have a choice. If you think this is an ln problem, because the formula is 1 over u du. The formula is the whole bottom is your u, okay? So if I make the whole bottom my u, the derivative of that is a chain rule. It is 2 times x squared plus 1. Take the power down by 1. Don't forget to multiply by the derivative of the inside. So what I have is 3x over 2 times x squared plus 1 times 2x. Do my x's cancel out? No, I mean, one of the x's cancels out, but that's not helpful. All of the x's have to cancel out. So guys, this is not an ln problem. Do you see how you logic this through? You say, okay, start all over. The bottom must not have been my u, okay? So guys, what is your u in this problem though, really? X squared plus 1. And since it wasn't the whole bottom, then you just do your regular u substitution. And even with the ln problem, you could have done the regular u substitution. I just taught you a shortcut, that's all, okay? Force this into a fraction, 1 fraction on the left, 1 fraction on the right, and equal sign in the middle, okay? Cross multiply, and I'll get dx is equal to du over 2x, okay? And then I replace 2 things. What 2 things do I replace? My u and my dx, right? So this becomes the integral of 3x over u squared times du over 2x. 3x over u squared times du over 2x. You good with that? Okay. Then you're going to have to ask yourself, do my x's cancel out? Do they? What scalar do I have that I could pull out? 3/2 integral of 1 u squared du. At this point, this right here should be an easy antiderivative or something on my formula sheet. Is it an easy antiderivative? Kind of. What do I have to do to make it an easy antiderivative? Yeah, move the 2 to the top, so that becomes a -2. And now it is an easy antiderivative. I'm going to add 1, divide by -1, I think. Divide by -1. Okay, so what I get is 3/2 times u to the -1/2 times -1, all right, plus c. Okay, what is this? This is ugly, but yeah, -3/2 over u, right? If you move this around properly, this is what you get. And that is a great answer. Of course, it is the wrong answer. What's my u equal to? X squared plus 1, right? And so there I am. That is the right answer. And of course, if you wanted your u up with a -1 power, that's fine. More power to you. Okay. All puns in this class are intended. Okay, I want to look at the difference between these 2 problems. Okay, so what I'm saying is I've taught you a shortcut, but a lot of students use it incorrectly. And I want to just point out the times that you can use it. For example, if you had this problem, how would you do this? U substitution, so this would be your u. Okay, what's the derivative of x squared? 2x. So you do, if you made the whole bottom your u, you'd ask yourself, do my x's cancel out? No. Okay, so whatever I'm doing, the u is not x squared. The u could be something else, but it's not x squared. What else can I do here? How do I do this problem? Move the x squared to the top. See, it looks really difficult because we've been doing a bunch of difficult problems. Does that make sense? And so you have to go back to, hey, when I get an easy problem, do I see that it's easy? You know what I'm saying? So we're going to add 1, divide by -1. So this answer is -3 x to the -1 plus c, which is -3 over x, I believe, plus c. Okay? So this was not an ln problem. Everybody good with that? The reason was because the x's didn't cancel out. Over here, okay, if I move the x up, so this would be 3x to -1 dx, okay? I'm going to add 1, divide by ding, 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 ding. Did you hear the ln bell? Okay, so that signifies, hey, that was an ln problem that I'm dealing with. Okay, so let's go backwards. Okay, do you see if I take out the 3, this becomes a lot more clear, right? If I take out the 3, then you look at this and you say, is this an easy antiderivative or is it something on my formula sheet? This actually is on my formula sheet, but in the terms of u's and not x's, right? So this is times the ln, instead of u, you'd say the ln of x plus c. Do you see how that works? Okay. So again, you've done so many hard problems. The easy ones are going to seem hard, okay? So just remember, you know how to do the easy ones. All right, here's a problem. I'm going to make the entire bottom my u. I'm just going to try to see if it's an ln problem. If this doesn't work, then what I do is I just make another u. I find another u and then do it again, okay? All right, what is the derivative of x squared plus 2x? I have to take the whole bottom. So what's the derivative of the whole bottom? 2x plus 2. Now I want you to think about it. Do my x's cancel out using real algebra here? I have x plus 1 over 2x plus 2. They actually do. They don't look like they do, but what can you factor on the bottom? And some of you guys are doing this, okay? Like some of you guys are doing this. I have no idea what you're doing. You're doing that. And I'm like, whoa, don't do that, okay? You can't do that because there are plus signs in there, okay? But what you can do is pull out the 2, okay? So if I pull out the 2, look what happens. Now, remember what I told you about the top? It's a family, right? Do the families cancel out? Yeah, I mean, we can't break up families, but we can certainly cancel them, okay? So the families are going to cancel out. What do they cancel out to? 1. So all of my x's cancel out. So what's left over, guys, again? 1/2. It's not 2. Is everybody good with that? 1/2 is what's left over. So this becomes 1/2 times the ln of the entire bottom. And again, this, So that means this only works when the entire bottom is my u and the x's canceled out, okay? One over 2x like this, 1 over 2x like that, the integral of that. Yeah, it'd be 1/2 ln of, yeah, okay, so like I told you, you know, integrals don't have unique answers. Does that make sense? So what I'm saying here isn't what you're saying, but you could be right because you did it a different way from me. Did you pull out the 1/2 or what did you do here? Okay, so that would be 1/2 integral of 1x dx, right? So then it'd be, okay, but then here, what are you saying is your u though? 2x isn't your u. Yeah, it'd just be x here, okay? Although, okay, now this is kind of weird. Okay, so the way you did it, if you pull it out of 1/2, that answer is 1/2 ln of x plus c, right? But if you did it the other way, yes, if you, yeah, this is interesting. But if you go this way, if you say this is your u, okay, then the derivative of 2x is what? 2. So that answer would be 1/2 times ln of 2x plus c. Okay, now that's kind of interesting, but this is interesting because we know that, yeah, I know that's where you're getting it, right? But how can both of these be the same thing and have different answers? Now, first of all, I need to tell you, remember what I told you about the c? The c absorbs a lot of constants. There are constants here that you may not be seeing right now, and let me show you why. 1 log fraction equals 2 log subtraction. But remember, 1 log multiplication, do you see 1 log multiplication equals what? 2 log summation. So this right here, this 1 log multiplication is actually equal to ln of 2 plus ln of x, right? 1 log fraction equals 2 log subtraction, but 1 log multiplication equals 2 log summation. But guys, if I distribute this 1/2, do you see what I get? Is 1/2 ln of 2 plus 1/2 ln of x plus c. Well, isn't this 1/2 ln of x plus c the same as this right here? What is this 1/2 ln of 2? It's just some number. Do you see that? So it gets absorbed in this c. Does that make sense? So it really is the same answer. You guys are the only class that saw that. I really try to go so fast you guys don't ask questions. But mm-hmm. 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 And then this one. Mm-hmm. Yeah. So you can see they're both good answers. And so when I grade your work, I actually have to, when I grade your work, I actually have to look at it. And if you get it wrong, and I can see it's wrong, then it's real obvious. But if you get it wrong, I can't see what's wrong. I have to look pretty much in detail with your integrations, see what you did wrong, or maybe you didn't do anything wrong. Okay. Did I skip a problem, or is this the next one? Okay. So guys, let's try ln on this one. Okay. This is going to be my u. Okay. The derivative of tangent x is what? Secant squared x. Question, do my x's cancel out on the top? Why, yes, they do. Okay, so that answer is going to be 1 times, I don't have to put 1 times, ln of the whole bottom, which is tangent x plus c. Okay, pretty easy. So this looks very intimidating, but you guys can see you can do this, right? Okay, so when we do a lot of these, then you start thinking that every fraction problem is an ln, but you guys notice it's not, right? Because if the x's don't cancel out, then it's not an ln problem. If you didn't make your entire bottom your u, it's not an ln problem, okay? How do you do this problem here? Yeah, move the x to the top. When it goes to the top, what does it become? -1. But how does it multiply with this here? Yeah, you have to distribute it, okay? So this problem would be x to -1 times x squared plus 5x minus 1 dx. And we've seen this problem before. I just want to point out this one's a little bit different because there's an integral that we just learned. So let's go ahead and distribute. What's x to -1 times x squared? Okay, you just add exponents. You guys good? Because the bases are the same. Okay, what's x to -1 times 5x? 5, yeah, just 5, because it's 5x to the 0, right? Because 1 plus -1 is 0, but what's x to the 0? 1, so that's just 5. Is everybody good with that? That's the hardest one students have trouble with. But let me say this. X to -1 times 5x. Isn't x to -1 really 1 over x times 5x? And so do you see the x's cancel out? And that's why it's 5. Okay. All right, let's look at this. What's x to -1 times -1? Negative x to -1 dx integral. Okay. So I thought I got to do one problem, but get excited, guys. Oh boy, look how many I get to do. 1, 2, 3. 3, oh boys. Okay, so let's do it. What's the integral of x? X squared over 2. What's the integral of 5? 5x. What's the integral of x to the -1? Well, let's try. You add 1, divide by ding, 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 ding. Did you hear the ln bell? Okay, so that tells you you could rewrite this to 1 over x or 1 over u. Okay, so this is going to be 1 over x. And what is the integral of 1 over x? There's a negative sign here. Ln of x. Is everybody good with that? Okay. Now what we're going to do today. It was ln of x plus c. Is that what you're saying? Yeah. Okay. Let's look at this problem. Now, whenever you have a division where the bottom and the top have the same power, and you're trying to integrate, so this has the same power as this, or if this power is bigger, you have to long divide first. Okay, on the problem before this, you didn't have to long divide. I mean, look at the problem before this. You didn't have to long divide because you could bring the x up, okay? But when you have a binomial on the bottom, so this is a binomial, it has two terms. If I bring this x squared plus 1 up, look what happens. X squared plus 1, negative 1, okay? You can't distribute it because it's stuck in this negative 1 thing. Does that make sense? You can't distribute it. If it didn't have this, I could FOIL or something, but it has this negative 1. You're just stuck right there. You have to do a U substitution. And since these have the same power, it's actually not even going to work. So if you have a fraction where the top is the same power or bigger than this, you're going to have to long divide first. So guys, can you take a look at your homework? Tell me which problems you're going to have to long divide on. Five. Five, 7, 8. But 5, you could avoid long dividing by doing what? Moving it to the top. 5, you could, but not 7 and 8. And what other number? I think there's one more. 9. And 9. Okay, so those are the ones you're going to have to long divide on. So we're going to get lots of practice on long dividing. And just a warning, I'm pretty sure you're going to hate it. Okay, but maybe we can make it a little bit easier. Those of you guys in college algebra, you should be pretty good at long dividing. So let's try this. Let's just do easy dividing first, okay? 17 divided by 5. The way you do this is you say 5 times what is 17. Do you remember that? You say 5 times what is 17. So what's the answer there? 3. I'm just doing 17 divided by 5, just because we're going to copy this pattern over here. Okay, so 17 divided by 5. 5 times what is 17? You'd say 3, right? Then 3 times 5 is what? 15. Then what would you do here? What operation? You would subtract. Once you subtracted, then you would carry down the next term. Do you remember that? But we're not going to, this one doesn't carry down any terms. Then you're going to add, that's the remainder. Do you remember that? And when you started this in 4th grade, you were like remainder 2. Do you remember that? The good old days, okay, when you had no homework? All right. Actually, did you guys have homework in grade school? Okay, they don't have homework anymore. My son has no homework. They took it out because homework is bad for kids. So they took it out. So they have no homework in grade school anymore. What? Yeah, because it stresses them out. Yeah. I think, honestly, I think it stresses the parents over. Yeah, I mean, I understand. And they spend all day at school. Yeah. Yeah, that's what I think too. But it's okay. I mean, I'm good with homework or not. The truth is, if you're pretty intelligent, it doesn't matter that much. But if you're having trouble, it probably would help if you had something. All right. So 15, okay, plus, and I don't know if you remember this. This is actually, you could actually put it there plus 2/5. Do you remember that? You could make this a fraction. You probably didn't learn this until maybe 6th grade. Okay, but this is really 3 2/5, right? We wouldn't put a plus sign there, but 3 2/5 really is 3 plus 2/5. Okay, so we're going to use the same principle over here. Okay, so here we go. We're going to long divide this. So this is the dividend, okay? And on the outside here, this is going to be the divisor. Those are really good words for an immigrant, by the way. Okay, so this right here, what I'm going to do, I'm just going to take the first term. So take the first term here and the first term here. And I'm going to say x squared times what gives me x squared. Like just over here, I said 5 times what gives me 17. So x squared times what gives me x squared? 1. So then you put a 1 right there. Okay, then you erase these little lines because you only use the first terms to do that. Otherwise, it's too overwhelming. Then you say 1 times this whole thing is what? What's 1 times this whole thing? X squared plus 1. Okay, what operation would I do here? Subtract. Okay, so be careful though. With algebra, when you subtract, you have to subtract the whole thing. Like you can't just subtract the first term. Okay, it's really hard to subtract vertically. Okay, so I'm going to write this horizontally. It's x squared plus x minus x squared plus 1. Do you see my problem here? It's x squared plus x minus x squared plus 1. Okay, then what I'm going to do is I'm going to distribute this negative. So what I get is x squared plus x minus x squared minus 1. And do you see that that answer is x minus 1? Okay, so that's what I get here, x minus 1. I actually don't write all this out, but I'm writing it out to show you guys that this is why it's so hard. But if you write it out horizontally, it's a lot easier to understand. Okay, so I get x minus 1. So then what you do is, actually, I usually look at this and say, okay, If this is the same power, then you do it again. So like if this is an x squared, or if it's a bigger power, then you do it again. But when this power is smaller than this power, then there's no number here, right? X squared times what gives you x? That's going smaller, okay? So this would basically become the remainder. But the whole thing is this. I've already used this x squared. I've already used this x, right? Because I said x minus 1. But I haven't used this 1. So I need to carry down the 1. But when you carry down the 1 in algebra, you don't carry down a 1. You carry down a plus 1. Does that make sense? Because it's algebra, okay? So then this becomes x minus 1 plus 1, which is what? X. So x is just the remainder because this power here is smaller than this power here. As soon as this power is smaller, it's the remainder. So what you do is you say plus x over x squared plus 1. Okay, so as soon as you've used up all these terms and you've got a remainder that's smaller than this power, then you're done. Okay, so what does this mean? This means that all of this up here, taking the integral of this is the same as taking the integral of that. This expression is equivalent of x squared plus x plus 1 over x squared plus 1, okay? And this was really hard to do. I thought I got to do one problem, but check this out. Oh boy, I get to do 2. And this is not two hard problems. It may look hard at first, but think about this. What's the integral of 1? X, okay, plus. What's the integral of x over x squared plus 1? Make this your u. What's the derivative of x squared plus 1? Okay, if I divide this by 2x, do my x's cancel out? Yes, what do they turn into? 1/2. So this is plus 1/2 times a log of x squared plus 1 plus c. And that is my answer, using long division. Did you like that? Okay, then there are 3 ln problems I want to do with you guys. And I want to tell you guys, just because the problem has an ln in it, doesn't mean it's a log problem, okay? What do I mean by that? Okay, if I make this my u, what's the derivative of x? 1. If I divide by 1 here, do my x's cancel out? No. So it's not going to be an ln answer problem, okay? Or not in the way I'm thinking. The way you do this is the way you've always done it before I confuse you today. Whatever is in your parentheses, that's your u, okay? So obviously this wasn't my u because it didn't work out. So make your parentheses equal to your u, okay? That means du dx is the derivative of ln of x. What's the derivative of ln of x? 1 over x. Cross multiply, guys. Be careful. On this one, you don't get a fraction when you cross multiply. Did you notice that? Dx is actually equal to x times du. You're going to replace 2 things. You're going to replace your u and you're going to replace your dx. So I'm going to circle those, okay? Whenever I see a circle, I'm going to replace it with u, or I'm going to replace it with my dx right there. Then I ask myself the question, do my x's cancel out? Why, yes, they do. So what do I have left? u9 du. Can I do that? Is that an easy antiderivative or something on my formula sheet? It is. Add 1, divide by 10. You get u to the 10th over 10 plus c, and that is a great answer. It's just the wrong answer. You need to go in and squish that ln of x into your 10. But be careful. That x belongs to the ln family, okay? So it needs to stay in parentheses. Else, you're taking the x out and raising it to the 10th power, which is not correct, okay? This 10 is only raised to the whole family ln of x, not just the x. See, because it's raised to the u here, or the u is raised to the 10. All right, let's do another one. You guys can do this one. What do I do when I have a square root? Yeah, write an exponent. What is the exponent with the square root? Yeah, anytime you guys see a square root, nobody can take the integral of that unless you change it to 1/2. Okay, do the same thing you did in the last problem. Make your u equal to ln of x. Then your derivative is going to be 1 over x. Then your dx is x du. This is the exact same thing you got in the last problem. You're going to replace 2 things. What 2 things are you going to replace? Your u and your dx. Question, do my x's cancel out? Do they? Using real algebra. Yes, so I get u to the 1/2 raised to u 1/2 du. Guys, is this an easy antiderivative? Add 1, divide by 3/2, but dividing by 3/2 is really multiplying by 2/3, so this is 2/3 u to the 3/2 plus Charlie, and that's the great answer. Just go back in though, put in your u, and that is the right answer. Okay, now the last one I want to show you is a little bit funky. This problem here, I'm just gonna have to tell you, make your u equal to ln of x. Like I have to tell you, you have to do that or it won't work. Okay, so this one you just have to know a problem like this, you use your ln of x. All 3 problems we've done, you use ln of x. Okay, do what you've done for the other problems. The derivative of that is 1 over x. If you cross multiply, you'll get dx is equal to x du. You're going to replace 2 things. You're going to replace your u and your dx. So that's 1 over x times u times x du. Do your x's cancel out? Do they? What do you get? 1 over u du. Is this an easy antiderivative or something on my formula sheet? Isn't this ln of u plus c? But guys, what's my u in this problem? What's my u? So look at what this answer is. You have to squeeze that u in. And so my answer is the ln of x plus c. Nice problem. All right. Okay, you guys are armed and dangerous for the homework. It is due tomorrow. Okay, so, and it shouldn't take you very long because you guys are pretty good at u substitution right now. The worst things are probably going to be doing the long divide. Okay. Do synthetic division here, just FYI. X times x squared is what?
Wait, which problem is this?
Number 7, I think. Okay. X times x squared is what? X, right? Well, I'm sorry. X times what is x squared? Oh, do you guys want me to finish it or not?
Yeah,
okay.
Yeah,
So then x times x plus 1 is x squared plus x. Do you see that? X times x plus 1. Then you're going to subtract this. So this will be x squared. Bye, guys. Make it a great day. This will be x squared minus 3x, and then minus, okay, so it's minus this quantity, right? So it's minus x squared plus x. So subtract this. This will be negative 3x minus x, which is negative 4x. Is that right? Negative 4x. Okay, so this is negative 4x. The hardest thing is the subtracting thing. Okay, and then you look at this and you say, well, you can take it 2 terms at a time. So I've already taken care of the x squared. I've taken care of this negative 3x because it's right here. Let me pull down a positive 2. Okay, so then I'll say x times what gives me negative 4x. You only look at the first term. X times what gives you negative 4x? Negative 4. Okay, then you multiply again. What's negative 4 times this whole x plus 1? Is that negative 4x minus 4? Do you see that? Okay, but then you subtract it. And the tricky part is subtracting this whole thing. And that's why I change it horizontal rather than vertically. So this is negative 4x plus 2 minus the quantity, negative 4x minus 4. So that's negative 4x plus 2 plus 4x plus 4. So I get 6 there. Okay, so 6 is your remainder. So plus 6 over x plus 1. And this is what I'm going to take the integral of.